in this video I want to talk to you about how many significant figures we record calculated values to. So what you've got in front of you here is some data. We've got the voltage, and this for example could be the voltage or potential difference across a bulb in a series circuit, and the current through that bulb. So we've got the voltage and the current, and from that we can work out the resistance. Okay, now obviously if we were doing this experiment we'd record more values of voltage and the corresponding values of current and calculate various resistances, plot a graph or whatever. Okay, but I just want to focus in here on when we calculate this value of resistance, how many significant figures do we quote it to? Okay, so let's calculate the resistance. Well, R equals V over I, as we know. So we've got 2 over 0.52, and that gives us a value of 3.8462. In fact, I think there are more figures on your calculator when you calculate that, but we'll just round it to that point there. Now, are you going to write that value into your table there? The answer is no. There's too many significant figures there. I know that. You probably know that as well. But how do we know that? Well, let's think about the data that we've used first of all. These bits of data that we've got here are values that we have recorded in an experiment. They're values that we've measured. And we know that our voltage here has a resolution, and often we write the resolution in the top of the table. 0.01 volts. Okay, we know that that's our resolution. How do we know that? Because the person here has recorded their results to 2 decimal places. Okay, and that's what we do whenever we record results. We always record them to the resolution of the instrument that we've used. Now, if you look at the instrument that you use to record voltage, it'll be this. Okay, so this voltmeter here, and if I turn that to there, that would be the scale that we would use. And you can see that this measures to 2 decimal places, okay? And therefore the resolution is plus or minus 0.01 volts, so I have to record all of my values to that resolution. The same with the current. If we turn this round to the setting for current, it records to 2 decimal places, okay? And that means that I have to record all of these values to 2 decimal places, and the resolution is 0.01 amps. Okay, so the significant figures of these two are determined for me by the resolutions of the instruments that I've used to record them. But the resistance value we haven't measured, we're calculating it, so we don't have a resolution for that. We can't use that to determine the number of significant figures that we're going to record that to. So the WJC give us a general rule of thumb to use here, or a rule of estimation, I suppose you could say. What we usually do is this: we quote our value of resistance, or our value that we've calculated, to the minimum number of significant figures used in the calculation. Now this is 3 sig fig, this is 2 sig fig, so we need to record this to 2 significant figures, okay? And there you go. So you quote your value that you've calculated to the minimum number of significant figures used in the calculation. Now that's the rule of thumb. If you really want to know, okay, this is a rule that allows us to sort of have a correct ballpark figure in terms of the number of significant figures. If you really want to know what number of significant figures to record it to, and be absolutely certain about the correct number of significant figures to record this to, you'd have to calculate the uncertainty in it. Okay, and you could do that by calculating the uncertainty in this and this. Okay, or the percentage uncertainty in this and this, adding them up to get the percentage uncertainty in this, and then calculate the uncertainty in this value, and that would tell you exactly what number of significant figures to record it to. Okay, but the general rule of thumb is we record calculated values to the minimum number of significant figures used in the calculation.